I'm Sergey. I'm a mobile engineer at Wix.com. And unfortunately already explained what we do at Wix. So we can dive into the NPM stuff right away. And I want to start by explaining why we are giving this talk about NPM. And so React Native implies that we have to deal with a lot of dependencies. If you create a new React Native project, like write React Native init, you will have about 1,000 of packages in your node module right away. And if you probably add more while you develop because you need some third-party libraries. That's a lot. Now you run npm install probably several times a day. You do it every time you switch a branch, and you do it every time you pull changes committed by your colleagues. So if with all those dependencies it would always work smoothly, it would be fine. Like sharing code is great, but it's not always that smooth. And sometimes you have issues, like you do npm install and something is not working. What do you do then? Then you can search Google for a solution, ask your friend, your colleague, or just wait. Sometimes you just wait until tomorrow, and the problem is solved automatically because there was a new release of some app. And that's okay, but probably that's not the best way to handle it. If you better know NPM, better understand NPM, then you might solve those issues faster yourself. And also sometimes prevent them if you configure your dependencies better, okay? So this is one reason for this talk. And I also have another reason, kind of a goal. I hope this talk will convince you that NPM environment is complicated and it's not stable enough, and we should talk about it. And maybe we can improve it, okay? And we will return to this thought in the last slide. So let's start, and we'll start by explaining what is NPM. NPM is actually three things. First, it's a site where you can search for packages or read documentations about NPM. The second is CLI, command line interface, which allows you to run commands like npm install. And the last one is a registry. That's actually the main part. It's home for a lot of JavaScript packages. And even if you use Yarn, you still use that registry, okay? Does anybody know what NPM stands for? What are those three letters? Yeah, Node Package Manager. So I thought it as well, and then I went to check this. And this is the NPM site. Let's see what it is. Nutella per minute. Interesting. Or maybe we eat nocturnal parakeet monitor. What? Noodles practicing medicine? You're getting the point. So I tried to search for it on Google, and there were like some weird explanations about it. One of those was that NPM was never node package management. Actually, it was for typing easily with one hand, NPM. I don't know. I think typing easily with one hand would be IOP, not NPM. It's not convenient. So I searched for it more, and I went to GitHub. And fortunately, there's history for all of that. And in the first commit of NPM, you can see that it is indeed Node Package Manager. That's what was at the beginning, but not anymore. And why? Because it's JavaScript. It started as Node Package Management, but it's not just for Node now. It's for web, and it's for React Native too. And they decided to change the name without changing the letters. Let's cover some basics. I will go over those really quickly, and then I'll show some simple demos for them. Package.json is for is files that defines your module or your app, its dependencies, and so on. npm init allows you to create new package.json actually. npm publish publishes your module. npm view fetches some data from the registry and shows it to you. npm install, you all know what it is, install packages. npm ls shows the packages installed already locally in your app or in module. npm pack is a nice command that will pack all your module like it would for publishing it, but without publishing. That's very nice. So let's start with our demos, and the best way to do it probably is to create a new package. I'll do it here. Okay, so I'll go, let's actually open another one. I'll go to tmp, I'll create a new directory. I'll call it awesome module. Okay. Oh no. I tried it before. Okay. I'll create a new one. Now I'll enter it, and I'll do npm init here to create a new package.json. Okay. So I'm okay with the name. It shows me suggests me some defaults. I go with the default, but I can change anything. Okay. Is this okay? Yes. After that, I have only one file in my directory, which is package.json. Now I can show you the content with just cat command or less, but I'm going to use here the JQ. If you're not familiar with this is a JSON query command, which shows it's a JSON files in a more nice way. So I can see some colors, and if I want to show some specific field in it, I will do like, I want to see scripts, I do dot scripts, and I see only the needed part, okay? Can you all see this? Like there will be a lot of demo here in this presentation. Can you all see this? Is that okay? Only the top, okay. So what I can try to do is, no, I think I'll try to, just a second. It should work. I want to make it shorter, but it's really hard to do it. Oh no. Okay, I can do it. I'll do it. Wait, yeah. You're right. That's what I'll do. Right, okay. Now is it better? Cool. So, this was a package.json, and I want to publish it right away, just a package.json. But where can I publish it? I don't want to publish it to the public repo. So I'm running Verdaccio here, which is a local registry for npm. Okay, so I'll be, during these demos, I will publish all my packages here and get them from there. So I'll do npm publish. That's it. And it's published. How do I know it's published? I can do npm view and show the data about it. npm view, awesome module, and I get some data. I want to publish a new version of it. So I'll change something inside package.json. Let's add a description, okay? Hello. And let's publish it again. I can't publish it though without incrementing the version, right? So I'll increment the version and can do it manually inside the package.json. I can also do it with npm version command. Let's increment the minor version. Doesn't really matter now. And let's publish it. Publish. Now I have two versions. How do I know? npm view. I'll do npm view on awesome module, and I'm only interested in versions. Sorry about that. And I also can see this in a JSON format. I'll show it as well. I can do --JSON, and I will see all the data in a nice JSON format. This is sometimes very useful because sometimes you have so many versions of the package, for instance, or so many data that that it only shows some part of it. But if you do --JSON, you will always get the whole info. Okay. So now let's change the description and publish it another version. Let's do it quickly. I don't like the hello. I'll do hi instead. I'll increment version once more, npm publish again. And now I want to, with view command, I want to check also module. I want to check its description field. It's high, but it's high now, not in the previous version. I can also check the previous version. I have just to add the version here with the add symbol, and we'll get not here, obviously. Okay, and I will get the old data. So you can get the data about all the versions. Now let's consume this package. This is also important. So I'll switch to, I probably have it as well, awesome app, probably, yeah, sure. So let's create another one, awesome module, awesome app. And here I also should create package.json, right? I should run npm init. I'm good with default, so I'll use the yes command, which provides the requested symbol as it's needed, and pipes it to the next command. Nice Unix command. And we have the package.json, and I want to install here, to add this dependency, my awesome module. Awesome module. And that's it. It's there. I can see it now. I can see that in my package.json, under dependencies, I will have also module. It was added automatically with the last version and the head. We will talk about it a bit later. Okay, so now I think the next thing is npm ls and npm pack. npm ls, I'll show it. I have a demo for it, so I'll go to the demo. It already has a lot of installed dependencies. I can do an npm ls here and get it. See all the dependencies installed. It shows me the tree, actually, what depends on what, and I can search for specific dependencies. This is very nice. Like, I'll search for his object. And when is it important to do it? It's very useful if you have some issue with some dependency and you want to check what uses it, why the dependency is there at all. And I also can check it on specific versions. So I'll add, for instance, this one. And I can only see specific version. Kind of the same as for description, for getting things from npm view. Okay, let's switch to another demo, and which is npm pack. npm pack. I have several files here, and I want to publish it. But before I want to publish it, I want to check what is going to be published. Why is it good? Because I don't want to publish something wrong, and then I will not be able to override the version. There's no way to override version. Once you publish something, it's there. Even if you can, even if you are unpublished, there's some time frame when you can unpublish. I think the version will still be not available for you. So if you publish something wrong with 1.0.0, you will not be able to republish it. Okay, so I want always to check that there's nothing wrong there. So I'll do npm pack command. It's that simple. And I have here now the npm pack tar archive. And I can see what's inside with npm, with tar tvf npm pack. Okay? And I see a lot of things, much more than I thought I will see. I see the build folder. Okay? And I don't want it. Don't want it there, because it's usually like, you're compiling something in iOS and have that build. You don't want to publish it, obviously. So I want to remove it. What is the way to remove it? Can anyone help me? How I can ignore it from publishing to npm? Yeah, npm ignore, or actually git ignore as well. I can add it to git ignore or npm ignore. Let's do it npm ignore. And I'll add the build folder there, build. Okay. Okay, or actually I'll start it with slash. The difference between starting it with slash and not is, if I start it without slash, it will be for any build file or folder in the repo. And I want it only for the folder starting at the root of the repo. And let's npm pack again, right? So, are we good now? What do you think? Yes? I'm not sure. what is the problem now? Problem now that we have npm pack archive inside. We forgot about it, right? So if you do this, always remember to remove it before you repack or publish. Or you can add this npm pack with wildcard to npm ignore as well, and to git ignore probably also. Okay, that was about npm pack. Let's switch to versioning. When you publish a module, you should specify its version. When you consume a module, you should specify its version. And npm uses something called semver, semantic versioning, for defining modules versions. So if you are a publisher, you publish a module, and you start with some version. It should be like 3 numbers, major, minor, patch. And then you want to publish an update. So you should follow the following rule, which is, if you have some breaking changes in your model, like you change the behavior or the API, you should increment major. If you have introduced some new features but not breaking anything, you should increment minor. And if it's bug fix, you should increment patch. There's also a very nice addition to that. When publishing modules, you can specify custom tags. And this is good for specifying, for instance, creating alpha versions, okay? And you can specify several tags. Actually, you can do -alpha.1.beta.2 or something like that. And it's useful for publishing pre-release versions and also for publishing in CI. In CI, we at Wix use this for publishing every version with the -build.number semantic, and then we can consume it, but we don't want anyone else to consume it, only the developer. For consumers, there's a lot of ways to specify a version. Like you can just specify a version, but you can also specify a range. And you have an OR operator, less than or equal operator, X, star, tilde, and caret. That's quite a lot, and it's confusing, I think. So I don't want to explain it like tell the definition because it's very confusing. Instead, I want to show you a nice tool, which is semver.npmjs.com. And this allows me to select a package. Let's switch to React. It has more versions. And I can specify here some version. So I'll specify it 15.5.2, okay? And I can see in green, like it selects me the versions here. So I can play with it and understand better what does what. So if I want any version greater than this, greater or equal, I can do more or equal, okay? And obviously, I can use some dash operator. Dash operator actually specifies a range, and it's exactly the same as specifying it with less or equal and more or equal. So I can do like this, and I have to specify spaces, otherwise it would be tags. Okay, so I can see it here. It's very nice. I want to explain the tilde and the caret operator because they're a bit confusing. So let's start with the tilde operator, and I'll add the tilde here. And like, why are there so many operators? It was kind of an evolution. You can specify anything without tilde and caret. You can do it just with the range operator or a simpler operator and or and. But there are those operators because it's a bit shorter. And tilde operator actually tells me that, tells the npm that I can, that the patch version is not fixed, and the minor and the major are fixed, okay? And it starts with the current version. Now, it makes sense, usually, because I start with specific version, I check my application or my module with that specific version, it works. I don't want anything lower than that, but I can do something higher than that. Like, can work with something higher than that, and if I trust the model, I also can specify the caret operator, and it will change the major as well. Okay, change the minor as well. It will not be fixed. But let's return to the tilde. And another thing about tilde: if I don't specify any patch, it's like specifying 0. If I don't specify minor though, the tilde operator replaces it with the same, like specifying dot star. Okay, so only the major is fixed. What was that? Are we back? Yes. Okay. So that is a tilde operator, and the caret operator is also quite confusing. It's, although it does fix only the first major version, but not always. If I do caret for another version like 0.1.2, let's say, .1.2, and I add caret here, I will not get, for some reason, I will not get 0.2, although it's minor. And that's because it starts with first non-zero, starts counting the major from first non-zero number, okay? So if I would specify 0.0.2, it will actually fix, it will be just the fixed version, like not specifying caret at all. Okay, that's something to remember. And another thing I have to mention about the versions is the tags. And if I specify, let's say 16 of 15 is better, 15.5.0-rc.1, okay, and I do greater or equal, you can see that I get only the tags before the 15.5.0 version, okay. After that, I don't get any tag, even if there would be, I don't know if there is here, rc.1 tag, it will not get it, okay. It will only get this specific rc and the next one, like 1, 2, and so on. And that also makes sense, right? Because I trust that RC and I trust the following versions, but not RC of another major release or even patch. Okay, let's continue with our presentation. There's also another tool, semver-r. It's a command line tool, and it's also useful. You can check on custom versions, which is nice. I'll not show it here. And now let's go over interesting package JSON fields. Let's start with dependencies. There are actually 5 types of dependencies. I'll talk only about 3. Dependencies, dev dependencies, and peer dependencies. When you use any module, you specify it as a dependency. For application, it doesn't really matter where you put it. But if you develop a module, then sometimes you bring dependencies which are not for your consumers. For instance, you write tests, you want to run them with jest. Okay, so you should bring jest, but your consumer will not run your tests, so they don't need jest. So we put it under dev dependency. That's the difference. Peer dependencies is for specifying dependencies which not your model is responsible to bring. Good example for that is any React Native third-party module. Let's say you develop a calendar, okay, component. You have to use to consume React and React Native, right? So you should import them. You should require them in your code, but you don't have. You can bring them. Why not? If you specify them as a dependency, when someone uses your module, it may bring several versions of React. And we really don't want that to happen, right? So you put it under peer dependency, usually with star or some as broad as you can specification about the version. Star, for trusted packages, star works best. If what happens if you put something under peer dependency and the consumer, in the application that consumes your model, there's no one brings it, no one puts that peer dependency under their dependencies. What will happen? When you do npm install. What? Right. Unfortunately, it's not even an error. It will still install the rest, but you will get a warning. It's better than nothing. And the same for versions. Sometimes you develop an app and you really don't want it to be published. It's your private code, right? And then if you accidentally type npm publish in the wrong directory, like in the directory of the app, it will get published. So to prevent it, just put private equals field in your JSON, into package JSON, and it will never be published with that command. It will be an error. Another thing in publish config, if you use private registry, that's usually the case, you want to publish your module, but not to the public repo. And you switch between those registries. So when you within, like, you run npm set config registry to the public registry, to npm.js, and do accidentally again npm public without remembering what is the current registry selected, then it will publish your code, your closed source code, to the public repo. You don't want to do that, so you can just set your private registry in the publish config setting, and it will be published to that specified URL always. Main is just the entry point of any module. So if you see something not working in another module, that's the first place to check. Okay, when you do require for some module, the first JS file imported is actually the one specified in the main. And repository is not mandatory field, but it's very suggested to use, because if you want someone to contribute to your module, to your project, or to open your, I don't know, pull request issues and so on, they will look at this field. It's also shown automatically at npm.js site. So let's all use it. It's nice. Sure. Yes. Mm-hmm. That's a good question. So you can live with that warning, because it's just a warning. But it depends. Like, whose model is this? It depends. Like, for example, new version of React Native, and today I get a warning that it requires the dependencies of React 16.3, but I have 16. For example. Yes, I get it. Okay, so. No, I think that, like, there's no good answer for that, because it's in this case usually you can't do much, because you want to use a newer version on that module, right? But it requires, but you can't use it with some dependency, right? Because some dependency required another version of that peer dependency, and then you have to talk with that developer of that module, like open him an issue, just open an issue. That's the only thing to do. Or you can do even more. You can open a pull request to check it with the new version, and if it works, you can put there a star or some broader range in that peer dependency. It will be even better. Okay, let's continue with the dependencies hell. There are so many dependencies in React Native projects, and not only in React Native. So I'll go with several demos here, and we start with a very simple one. I want to show multiple versions of the same package. So let's go to a new demo and multiple versions. Okay, so I'll run a script that prepares it. It will unpublish several packages and publish specific version of them. Okay. Again, it's running on Verdacho on my local, on this machine, so it will be easier for me to show it. And I published here 2 versions of lib. Okay, I published A and B. Now here, in the app folder, I have package.json file. I don't have anything else, just package.json. And it requires A and B, so I'll do npm install. Okay. And the thing is that A requires one version of the library, and B requires another version of the library. So if I do npm ls now, I will get 2 different versions, which is, like, we got used to it. Everyone probably knows it, but I want to talk that it's not trivial. In other systems, you will not get this thing. If you work with, I don't know, with C compiler and link those compiled files, like in iOS or Android native, for instance, you will not be able to use the same library with two different versions in the same app because of conflicts between the names. The linker will refuse to do it for you. Okay, but in NPM it's possible. In Node environment and Metro Bundler and Webpack, it's possible. Why? Because if you look at the structure, let's run a find command here. Find package JSON. We have lib installed under like you can have nested node modules. So B is under node modules, but it has its own node modules, and lib is inside. Okay, so when B looks for lib, it starts looking in local node modules folder. If there's lib, fine. If no, it goes one level up and search for node modules there, like A will do here, because lib, the second version of the lib, is installed under node modules of the application. So when A requires it, it looks for, tries to find it in A/node modules. It's not there, so it goes one level up and finds the version. Okay. The next demo is duplicated version of the same package. Let me run the script again now for duplicated versions. And again, unpublish something and publish it again. It's a bit different configuration now. I published two versions of lib and several modules. Okay, and now two of them require one version of lib, and two require something else. Let me show it for you. I'll do npm view just to check what uses what. I'll do npm view on A, B, C, and D. That's too much, so I'll do it on a variable and run it in a loop. I'll do npm view, and I want to see the dependencies. I'll do a for loop. Sorry. Oops. What's wrong? I didn't write $p here. Okay. So A and B requires lib of version 1, and C and D requires lib of version 2. Let's do npm install now. And let's see what we get. npm ls will now show me that there are 4 versions here, one deduped, right? But there are 2 others. If I run my find command, I will indeed see the same, like there's lib package JSON at the top level of node modules, and there are 2 nested node modules with lib. Why is that? We don't have another way around, because the top level already used, like C requires lib, and it should find it somewhere, and it can't find it at the upper level, so it has to have it inside its own node modules. And that actually means that we duplicate the same version, like instances of the same version across our node modules. For instance, in our app, we have probably 10 versions of 10 instances of the same version of Lodash installed in our node modules, and those are like, we have like probably 3 or 4 versions overall of Lodash used, but only one can be placed at the top level of node modules. Okay, that brings to like duplication, and because of that's one of the reasons why node modules take so much space on your disk. Next example is transitive dependencies. And it's going to be a bit more complicated now. Let's run a new script for this folder. I published lib and day, and I will publish a new version of lib a bit later. So let's do npm view on A dependencies, and we can see that. Sorry, I wanted to show it on the package.json. Okay, so let's have a look at the package.json. Dependencies package.json. So the app requires only A of a specific version. Okay, I'll do npm install here now, and obviously I'll get it installed. Okay. Now let's imagine that this is a package that is developed by some guy, and he commits it to their Git remote, and another guy pulls it. Okay, so I'll create here another pane for a new guy. Do it magenta. Okay, and let's create a copy of that app. Like the green guy committed it to Git, and the magenta guy cloned the repo. So we'll do a new folder here, app copy. Okay, we'll go there, and we'll copy the package.json from the app, because that's the only file I have here. Okay, so I have package.json here as well. Let me continue with the script and publish another version of lib, and let me do npm install here. Okay, and what do we have here now? We have not quite the same picture. We only required A, but it required the new version of lib. Now the thing is, what happens here, that magenta guy tries to run his application, and he can't because something broke. Okay, so he goes to the green guy and tells him, you just broke our app. And the green guy asks for what is the reason, well, like what is the error? The magenta guy shows him the error, and the green guy says, it's nothing to do with my code. Okay, so they sit and they try to understand what happened, and then they see what actually happens is that the A module specified star as its dependency, as the version of lib. And what can they do now? Like, that's kind of a problem. They specified fixed version in their package.json, but the results are different, and that's something we usually want to avoid. Like, you want to have exactly the same picture if you have on different machines, if they are on the same Git commit, right? So that's not quite the case. So let's try to fix it, and I'll try to fix it with the next demo, which is for package lock. Do you use package locks, or do you remove it? Let's check this for a second. How many people remove package lock? Okay, sometimes. How many people use it? Okay, a lot. Let's go. So let's show a demo on it. It's actually quite the same configuration, I think. But I'll still do it. I'm not sure about it, so I'll do a package lock here. Okay, so let's do npm install here, and I'll do npmls. Okay, and it's the same picture, and let's create the magenta guy again. So let's create an app copy dir here and copy, but this time I will copy package.json as well, package log.json as well. So I'll do app package, two of them here now, app copy. Okay, I'll cd to app copy. I'll continue the script. Before I do it, I have to prove that it's indeed the same picture. So dependencies. And indeed, lib is still of this, has a star as its pattern for version. And I'll do npm install now. And it really worked. I'm getting the same picture. So does it solve the problem or not? Excuse me? Yes, but not every problem, right? Sure. So what doesn't it solve? Which problem? They what? How how can you upgrade it? Like changing it in package.json? Okay. I'm not sure about that. I had something else in mind. Um, okay, so the thing is that if you have the same package lock, you will have exactly the same picture. But the problem is actually, maybe you were talking about that exactly, I'm not sure. But the problem is now updating things, right? I want to update some package. I want to update A or install something else. But if the picture in my node models is according only to package lock JSON, then I won't be able to update something easily. I will have to remove package lock, right? And to rewrite it. Okay. So now what happened is npm 5.0 had this behavior. Package lock was the main thing. Like if there's package lock, you can't upgrade packages, you can't install new packages. You have to remove package lock, and it's inconvenient. So they actually broke the API and changed it to be other way around. And now if you change the version in package.json, it will take the new version of that model of A, for instance. And that's okay, kind of. We just need to know it. It's okay because package.json is also committed, so they both will get the same picture. But that's something to remember. And actually, there's another thing that is not solved. It's we, for instance, can't use it because it's not always working well. There are bugs in it. Okay, but that's another issue. Okay, our next demo is npm shrinkwrap JSON. Do we have time for more demos? Okay, so I'll show this one as well. npm shrinkwrap is, let's switch to this. npm shrinkwrap. It's again kind of the same picture, but not exactly this time. Okay, so I'll do npm install here, and I'll do npm ls. Okay, and I'll prove that it's kind of the same picture with, again, npm view a dependencies. Okay, and a again requires star lib with version star. And let's go to the magenta guy. npm shrinkwrap. Let's create app copy and copy. But let's not copy the package.json now again, like in the first example where we had a problem. Okay, let's just copy the package.json. Let's cd to app copy, continue the script, publish the new version. Okay, and now do npm install here. And if I run npm ls, then I now somehow again have the same picture, but I didn't copy package lock. So what happened? And what happened is that we have shrinkwrap file. If I do npm find here, let's close the magenta guy. I think I don't need him anymore. npm, let's do s-l in node modules and a. Okay, so a comes with npm shrinkwrap file. npm shrinkwrap is has the same format as package log JSON. It's actually the same file, but it's renamed. And the difference is you can't publish your package log JSON to the registry. If you have package log, it will be always ignored. And if you rename it to npm shrinkwrap or run npm shrinkwrap command, it will rename it. It will be published with your module, and then you will get, if you do npm ls here, like you will always get all the dependencies of A inside A. Okay, so if you like do shrinkwrap on module, you create a shrink-up file and publish it for a module that has 100 dependencies, it will all be brought by the npm and put under your under that module, and there will be no flattenization. It means if even there's the same version of lib at another place, it's the same version, it will not go up. Okay, although it could if there was no shrink-up. So it's a tool that we should be aware of. It's sometimes required. npm suggests not to use it because then there will be no flattenization. Okay, and that's not very good. But it sometimes solves problem for modules. Like we, for instance, want to use it sometimes in our app. Unfortunately, it also has some issues, like the issue that it will bring all the dependencies inside. Okay, I think I'll skip. We are kind of running out of time, so I'll skip the first two demos and only show the bin demo. It's kind of nice, and it's about scripts. Okay, let's switch to this demo. I'm publishing lib, okay, just lib, and let's see what I have here. I have here package.json again, and let's see what we have inside the package.json. So inside the package.json, I told you we'll do it with a more nice command. So let's do it that way. We have the script section, and script says there's some s, and it points to some x. So what does it mean? I'll try to run npm run s, okay? And for that, let's see it again. I didn't do npm install. Yeah, probably it will not work that way. Okay, so let's do it again. Let's see what is in script. Let's do npm run s, and I see the line. This is some x script, which is printed but somewhat. Okay. By what? What is it? What if I do just s, not s, because s points to x? S means s specifies that we should run x. Okay, when I do npm run s, actually what should run is x, right? So I'll run x, but it will not run. Why? Because it's not in my path. So where is it? So what npm actually does when we run it, it does npm run, and sorry, it runs files under it adds node models.bin to the path environment. Okay, so it does something like that. I'll do it here as well. I run it. Parentheses is for running it in a subshell, so I won't change my path environment variable, and then I'll run x now. So again, I'm running x, but I'm changing the path, and now it works. Okay, so npm run always adds node models /bin to your path environment variable, and then execute the script. And what do I have? What is it actually, and how it got there? X points to /lib/sumx. What is sumx? It's under lib, so let's check what it is. Lib sumx. Okay, so there is such file, but why do we have the link? We have that link because in lib's package.json, and I can see it from the level above, lib package.json, I have a section bin, and the specification in this section will tell actually that for each key there will be created the link under node models.bin of the consuming module or application with the name x, and it will point to my script called sumx. Okay. Okay. So I hope you saw today a bit of how complicated npm and our environment is, and let's think for a few minutes how maybe we can improve it, what we can do, and what are the issues. And the first issue, I think, is that npm is not reliable enough today. And why is it important? Like there are some bugs, a lot of bugs actually. They break API sometimes. Okay, and I'm not complaining about npm. It's a project that is huge, and it's very, very helpful to all of us. It's really good project, but I think we can improve it. So why it is so important to be reliable? Because it's infrastructure. And imagine you have some bug in your application. You probably never blame your CPU for that, or TCP/IP protocol implemented in the OS, right? You trust those systems. But we can't trust NPM, and when the magenta guy comes to the green guy, they actually don't trust NPM, and they should check if that's not an issue with NPM. So we should try somehow to make it more reliable. We also want it probably to be more simplified, more easy to use. Not all those operators and transitive dependencies, it's all very complicated. I actually started some POC recently, like a week ago, that tries to address those two issues. Like to be like, I want to simplify it, just the npm install. Instead of handling all the npm install has a lot of edge cases. Like you can do npm install and install specific package or brigade specific package. And it's very complicated because if you have the whole structure under node modules and you don't want to remove all node modules, just update specific package, it's quite complicated task. What I am trying to do is not handle those edge cases, but only to do stable npm install, fresh npm install, which will be reliable and simple, and only handle that case. We want it to be faster. npm 3 was slow. npm then we had yarn that was fast, relatively fast. Then we get then npm published npm 5, which was comparable to yarn. Then don't know how many of you know, but there's npm CI, which was introduced several months ago, and npm CI allows installing dependencies by looking at the package log and package JSON, but without going and checking updates. So it will always install the version specified in the package log JSON. Okay, so it's kind of a npm 5.0 behavior, and it's really, really fast. Like it's at least 5 times faster, I think, than the regular npm. And you can use it in CI, and you can also maybe use it daily to synchronize commit. It has also some issues, so we unfortunately can't use it in our big app because it doesn't work. This is debatable. Like I think that maybe the consuming modules or applications should have some control over transitive dependencies. So if there is a bug in some transitive dependency and we wait for tomorrow until someone fixes it, maybe instead we can just say, no, I do want the previous version of that specific module. And that would be great. NPM doesn't have, as far as I know, doesn't have something like that. Yarn actually has something like that, but I'm not sure how well it works. I tried it once a while ago and it didn't work quite well. But why is it debatable? Because it will again complicate things, and I'm not sure it's a great way to do it, but I think we should at least talk about that. And the last thing, and probably very relevant to all of us, if we publish modules, I suggest that we use as few dependencies as we can. And this is a bit weird, because NPM is about code sharing. So why would I say that? Why to use less dependencies? We want to share code with other developers. Now, because of the complication and the issues we have, but it's hard to write without dependencies. It's really like contradicting sentences. So what I think is a good way is to start with dependencies. It's okay. Like you create a new project and you publish it, and you want to publish it quickly, so use whatever dependencies you want. But then if the project becomes popular, like the case with React Native, then I think that too many dependencies is not good, and we should try to reduce them. We can reduce them by just rewriting them ourselves. Okay, usually you can do it to some extent at least, because you don't need all the functionality from those dependencies, just some parts, and you can rewrite it if the project becomes popular. And also, we can do something that is less nice, but NPM uses it, for instance. You can use bundle dependencies, and it's kind of shrink wrap thing. It's less nice, but it should be considered as well, I think. But again, better to just not use so many dependencies. Okay, that's it. Thank you. The demos are available. If you want to play with it, you can do it. They are available at an open source repo. So thank you. Yes, man.